Welcome to class. Ms. Tessler here. So far, you have used tape diagrams to represent and decompose fractions. Today, you will learn to represent fractions using area models. Area models will help us find equivalent fractions. All you need is paper and pencil or your personal whiteboard. Remember to pause the video whenever you need time to think, write, or draw. Let's jump right in. First, draw an area model like mine. Partition the whole into 5 equal parts. Now, shade one of them. If the entire figure represents 1, what fractional part is shaded? One-fifth. Next, draw one horizontal dotted line to decompose the whole into 2 equal rows, like this. What happened? Describe what you see now. Maybe you noticed that there were 5 equal parts at first, but now there are 10. We made one row into 2, so we have twice as many units now. By themselves, the solid lines create 5 parts, so the solid lines show fifths. What do the dotted lines make? What do we call these new pieces? Tenths. Notice where we shaded 1/5. How many tenths are shaded? Here is 1/10. And here is another 10th. So 2 tenths are shaded. But did the shaded area change? Did we shade more or erase any? No, it's the same amount. We just made smaller unit. What relationship does this show between 1/5 and 2 tenths? It shows they are the same. They are equivalent. How could we show this as an addition sentence? Let's use the smaller units, tenths, to add up to the larger unit, 1/5. Pause the video to write an addition sentence. Ready? We could write that 1/5 equals 1/10 plus 1/10, and all of that is equal to 2 tenths. I'll include parentheses to show that these 2 tenths are both part of this 1/5. So our area model and our addition sentence both show that 1/5 and 2 tenths are equivalent. Great job! Find room on your page for another. This time, draw an area model that is partitioned into 3 equal parts. Shade one of them. If the entire figure represents 1, what fraction is shaded? One-third. I'm thinking we can make twelfths. How many twelfths are in 1/3? We can use the area model to figure that out. Like the last problem, we could draw horizontal dotted lines to decompose the thirds into twelfths. Think, write, or draw for a moment. How can we make 3 pieces into 12 while keeping the area the same? I know that 4 3s makes 12. 3, 6, 9, 12. So I think we need to decompose our thirds into 4 smaller parts to make twelfths. Pause the video and decompose your thirds into twelfths. Here's mine. How many lines did you draw? I drew 3 horizontal lines to make 4 rows. Do we both have 12 parts? Notice the part we shaded in, 1/3. How many twelfths are shaded? 4 twelfths. Pause the video and write this decomposition as an addition sentence. How can you add the units to show their relationship? The units we add to make 1/3 are twelfths, and we add 4 of them together, which makes 4 twelfths. Again, I'll use parentheses to show that these 4 twelfths came from 1/3. This time, let's also try writing it as a multiplication sentence. What would that look like? Multiplying 4 times 1/12 is another way to represent adding 1/12 4 times. So, from this model and these equations, we can say that 1/3 and 4 twelfths are equivalent. Here is a tape diagram that also shows 1/3 decomposed into twelfths. What is similar about the area model and the tape diagram? What is different? Both models show the whole and show parts or units. We used dotted lines on both to decompose the larger units into the smaller units. The tape diagram is one long strip, so we can count the units across in one direction. Since the tape diagram is one long strip, we have to decompose each unit individually. The area model has rows and columns. When we partition with a line going one way for one unit, like thirds, vertical, and a different way for the smaller unit, like the twelfths, horizontal, we could decompose all the larger units at once. I like how that helps me see the relationship between the 2 units. What do you think about these 2 models? How is the area model helpful? Let's do one more area model together today. Ready, set, let's go. This time, I have a guess, and I want you to use the area model to tell me if it's true, okay? Here it is. 1/2 equals 5/10. Do you think these fractions will be equivalent? Represent the decomposition using an area model. Pause the video for as long as you need. So what do you think? Here's what I did. Notice anything we did the same and anything we did differently. First, I drew the whole model. Then I partitioned it in half by drawing one line. I made 2 equal parts. I shaded in one to show 1/2, one of the 2 parts. I want to compare 1/2, 2 units in the whole, to 5/10 with 10 units in the whole. So I need to decompose 2 parts into 10. I know 5 2s make 10, so I think I need 5 rows. I drew 4 dotted lines to decompose. Now I have 10 parts. Let me count how many are inside of 1/2, the area I shaded. 5/10 is the same amount as 1/2, so yes, they are equivalent. We decomposed 1/2 to find that it was equivalent to 5/10. Now, write this decomposition as a sum of units. Show that they're equivalent using addition. The units we add up to make 1/2 are tenths. These parentheses show that they're all part of the same half. Last but not least, represent these equivalent fractions using multiplication. How can you show multiplying tenths to make 1/2? We can say that 1/2 is equal to 5 times 1/10. and that equals 5/10. You've done such a great job with me so far. You are ready to try the problem set on your own. The must-do problems are on the screen.